there's not a lot of short-term solutions that are really effective, at least in my opinion. Well, there is one. If you can get somebody crazy enough to go up on your roof that's covered with ice and snow and clear it, that'll eliminate the problem. However, that has its own problems. Number one, you can't really do it from the ground. Maybe in special, particular circumstances you could, but typically you can't really get all the snow off the roof from the ground. As I said earlier, partial removal of the snow just causes a secondary ice dam to form farther up the roof. And even if you can go up on the roof, it's relatively not completely crazy, on a low slope, low roof. You're more than likely going to damage the shingles by scraping the snow off and walking on them and, you know, that type of thing. But really, in most buildings, it's very dangerous to try to do that. And, you know, the problem with that, too, is you cleared the snow and everything off today, and on Friday it snows again. So they're back to, so you basically could be faced with the situation of sending people on the roof constantly throughout the winter to clear ice and snow off, or, you know, you're just going to have the problem form the next time it snows. So that's not recommended, you know, in maybe some extreme, short, isolated situation, but I wouldn't recommend doing that. I think it's not cost effective and it's dangerous. Removal of gutters, I talked about earlier. Again, a very temporary solution. About 20 years ago, we had a really bad winter with ice damming in the mid-90s, and we were working at a site in East Brunswick that took off and put back their gutters, I think 4 or 5 times during the winter, because they pull them off, the snow would melt, they put them back up, it would snow again. Pull them off, you know, and it really didn't do anything except cost them money for pulling the gutters on and off. But snow melt devices, there's lots of different kinds, heat cables, stuff you put in the gutters, and they're all pretty much, they all do the same thing. They provide an electrically heated cable that will melt the snow at the edge of the roof. These are, except again in isolated particular circumstances, and I'll give you an example. We had a site where at the rear of the building they had like a shed roof on the first floor that covered patios, right? And those roofs were 6 feet wide, 5 feet wide, and they had real severe problems with ice dams. Now, in that particular instance, because the cable could actually melt all of the snow on the entire section of roof, we actually recommended that they do that there just because of that. If it was on a main roof that's 20, 25 feet long, and you're melting the snow off of the first 3 or 4 feet, the same issue would occur with clearing the snow manually off the first 3 or 4 feet. You can allow secondary ice dams to form above the extent of the cables. And so you'll keep the edge of the roof clear, but further up it'll ice up, and you'll potentially have the same water infiltration problems, only pushed up the roof, 5 feet. These are also problematic in the maintenance of them, how they operate. Are they on timers, thermostats, manually controlled? Who's going to control them? Who decides when to turn them on? Do they stay on all winter, or do they, So there's a lot of just operational situations, but the bottom line is they don't really solve the problem. Again, in the particular situation they might, but in a general situation they don't. And we don't typically recommend them. We think that they, as far as the cost and everything, it doesn't really justify the results you get in most situations. But again, you have to look at it individually and decide if in a particular area or certain types of situations that they might be effective. This is also a short-term kind of home-style solution. You fill up pantyhose or some other thing with ice melt, and you get it up on the edge of the roof, and what will happen is that chemical will melt the ice in a particular area. Now, the problem with that is it's, in a multi-family situation, multi-building housing, I mean, you're not going to do that on every building. But if there's a particular area over somebody's front door where icicles are hitting people in the head or something, I mean, that is a possible solution for short term. More long-term solutions. E-flashing is pretty common. E-flashing is basically addressing the edge of the roof with a combination of ice membrane, or ice and water membrane, ice and water shield is what most people refer to it, and flashings, drip edges at the edge of the roof, and so forth. And what this does is it doesn't prevent the ice dams from forming, obviously, but it seals the edge of the roof so that the water can't penetrate into the interior. And the membranes used are they're self-adhering, they're self-sealing, so the nails from the shingles, when they go through them, don't allow a path for the water. They seal around the nails and so forth. And this is probably the most effective thing that could be done in order to minimize what your problems are from ice dam. The code requires that if you install this ice shield, that it has to extend 24 inches horizontally from the outside wall in. Now, you raise that up on a plane, that can be more than 24 inches, and depending on the slope of the roof, can be more than this 36-inch wide rolls that the material comes in. So when we spec this, we do a calculation to provide the adequate amount that's needed. Now, sometimes, depending on the particular site and their history of ice dams, you go even further up the roof with 2 or 3 layers or rows of the material, because they've had a history of ice dams farther up in the valleys and other areas that extend out. So you have to tailor the installation of this material to the particular situation, but it's pretty effective. We also, you can see it in this diagram, where you have differences in elevations of roofs. You put that in the seam between the vertical wall and the roof, so that anything that's getting through the step flashing there would not be able to get inside. And and just other vulnerable areas. In my experience, using it at the rates is probably a little bit of an overkill. We don't usually have too many problems there from ice dams. The ice dams occur down at the eaves and in these areas where you got valleys and changes of elevation where ice and snow tend to accumulate. The main goal of this is to keep the water that's generated from the ice dams from penetrating inside, which is where people see it's a problem, and that's what you're trying to prevent there, or at least minimize. And each situation has to really be looked at individually. Sometimes you have a roof where on the typical eaves they don't have a problem, but when you get into valleys like here or up in here, they have specific locations where there's issues. Those you have to address a little more aggressively, whereas the general condition can just get the standard installation of material. I didn't mention this, but this, what they're doing here is what's called creating a cold roof. So what they're doing is they're raising the actual plane where the shingles are installed above the top of the attic space, and trying to maintain in these spaces air temperature the same as outside, which will prevent the transfer of heat. Obviously, that's a lot more expensive to do, than just putting shingles on the roof, right? You're putting framing, more sheathing, and then shingles. And typically around here, it's not, the cost isn't justified because you just don't have the problem on a, I know after the last 2 years you might think that, but prior to that, I don't think we had ice damming for 5 or 6 years, major ice damming around here. So that is a solution that would be a long-term permanent solution, but you'd have to, if you're thinking about that, you'd have to really assess whether the cost was worth it or not. And again, talking about ventilation, making sure that you have good ventilation to get rid of the warm air as quickly as possible, and then minimize your heat sources of allowing the warm air into the attic. Thicker insulation, care in looking at penetrations, not venting dryers and bathroom exhausts into the attic space, get them directly to the outside, that type of thing. If you can affect the cold roof, you'll end up with a snow melt pattern looking like this, where it stays uniform and it melts off because of the heat of the sun and the process of the snow evaporating, and it doesn't create that running water effect down to build up ice at the eaves. And here's a kind of a typical, as the process goes along, the snow stays in the middle of the roof and it starts to melt from the outside in. And that's a roof that's got a lot of transfer of cold air into the attic to ventilate it and minimal escape of warm air into the attic.